everyone, today I'm going to talk about stoichiometry. Oh. Okay. Oh. Okay, so everyday stoichiometry. So what is stoichiometry? So stoichiometry is to balance equation. So first I'm going to use a sandwich example. A ham sandwich. This is a sandwich recipe. You need 2 slices of ham, a slice of cheese, a slice of tomatoes, 5 pickles, and 2 slices of bread. So you can write this in the equation. You write this in the equations. 2h plus c plus t plus 5p plus 2b equals h2 ctp 5b2. Okay, so let's calculate. Oh, so let's this equations. Okay. So what are coefficients? So what are coefficients? Coefficient is the numbers. What number? So coefficient is the numbers. So this number. So like the 2h, the 2 is the coefficient. And 5 is the coefficient too. Okay, and the 2 is a coefficient. So this is a coefficient. Then, okay. So what is stoichiometry? Stoichiometry is to calculate the product or the reactants, the moles, the mass, or the velocity of the reactant or product. Maybe they tell you the reactant and to calculate other reaction or the product. What is mole ratio? So the mole ratio is same as the coefficient ratio. So the coefficient ratio number is the mole ratios. So like you can say 1 mole of element plus 1 mole of element is equal to things. So the coefficient ratio is 1 to 1 and the mole ratio is 1 to 1 too. Some simple problems. So how many moles of ammonia are produced? 4.2 moles of hydrogen are reacted with an excess nitrogen. So now we can see the nitrogen is excess nitrogen. So we have 4.2 and we can see the coefficient. Hydrogen is 3 and the product is 2. So 3 to 2 is equal to 4.2 to a mole, unknown number. So we can cross times. Divide. Okay. So it's equal to 2.8 moles. So there's 2.8 moles of reactant product. Okay. Another simple problem, the mole ratio. So 0.5 moles of magnesium hydroxide is present. How many moles of phosphoric acid is required to react? So, okay, so we use a pen. Okay, so how to do it? So first we need to see the coefficient. It's 3. Okay, and the phosphoric acid is right here. So it's 2. We can see the coefficient is 2. So 3 to 2 is equal to 0.05 over an unknown number. It's a moles. So we can find the cross times again. 0.5 times 2 divided by 3. Okay, so 0.0333, you can, it's same as 1 over 13. So we can see 1 over 13 is equal to, yes, 0.033333. Okay, oh, okay, next page. So mass to mole stoichiometry. What is mass to mole stoichiometry? So it's you change mass and more. Maybe you change mass to mole, or you change from mole to mass. Okay, so first, okay, mass to mole problem. Oh, it's a little, okay, never mind. Okay, so first we can see the tin and hydrogen fluoride are produced and become tin fluoride and hydrogen. So how many hydrogen fluoride are required to react with 75 grams of T? So 75 grams of T. So we need to know how many moles. So 75 over the molar mass of T. So how many is the molar mass of T? So I wrote it right here. So I see it's this number. Okay. So we divide it. Okay. So 0.63 and blah 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 blah. Okay. So we round it to 0.63. So 0.63 moles to an S unknown number is equal to, see, we need to see this and this, the ratio. This 1 and this 2. So then we cross times, do it again. 1.26. Okay, so the answer is 1.26 moles. Okay. Mass to mole stoichiometry. So mass to mole is same, but it's reversed. Maybe you change from mass to mole, or you change from mole to mass. So it's just opposite. Okay, so there's another problem. Okay, so with this, okay, so there's another problem. Okay, so mole to mass problem. Then okay, so how many mass of oxygen gas is consumed in a reaction that produces in 4.6 moles of SO2? So first we need to know the ratio again. Okay, so it's asking for oxygen. So where's oxygen? Oxygen is right here. So this is free, and we can find how many mass of oxygen. Okay, so we need to find the SO2. The coefficient is 2, and oxygen is 3. So 3 and 2, so the mass is 2 and 3. So 2 to 3 is equal to 4.6 over 2x. X is an unknown number. So cross times again. Okay, x is equal to 6.9 moles. Okay, so then we times the molar mass, so we can know how much grams. So what's the molar mass of oxygen? Oxygen is 16, but there's O2, so it's 32. 7 times 221. Yes, it's correct. Okay. Well, ooh. Okay. Mass to mass stoichiometry. So now we change from mass to mass, but there's no mass ratio. There's only mole ratio. So to change from mass to mole and make a ratio, and then turn back the mass. Oh, so mass to mass. So 15 grams of chlorine gas. Okay, so with liquid sulfur and produce sulfur, yeah, chlorine. Okay, just that. So what is so how much is produced? So how many product is produced in grams? Okay, so how many grams of chlorine we need to know first? 15 grams. But I said that there's no mass ratio. There's only mole ratio. So we need to convert it into moles. So how to convert it? So we need to know the molar mass. So but it's Cl2. So we need to times the molar mass by 2. So Cl is equal to 35.5 and times 2 is equal to 71. So 15, and that's 15. 15 divided by 21 is equal to 0.21. 0.21 moles. So now we need to times the molar mass to get, because the mole ratio is 1 and 1, so we don't need to times any number. Then we just times the molar mass to get the grams. So how much? So I told you chlorine is 71, but how much is sulfur? Sulfur is 32 times 2 is equal to 64 because it's S2. Then we add it to okay, so 28.35 grams. Okay, mass to mass, another question. Mass to mass stoichiometry. So neon nitrates will decompose itself, become 2 water. Okay, so there's 45 grams of ammonium nitrate. So how much grams of each product? Okay, so because the mole ratio, we can find it. Okay, so first we need to convert it into mole ratio. So ammonium nitrate, we need to know the molar mass is this number. So 45.7 divided by 18.66, and we need to know the number. Okay, so now we need to use a calculator. Okay, it's going to about 0.57. So 0.57. So the mole ratio is 1 to 1, and this and mole 2. So we just times the molar mass. So the molar mass is how much? 44. Oh, wait a second. Where is it? Oh, here is it. Okay. So we just times the 44. To 25.08. Okay, grams. So then we find the number. And now the mole ratio is 2, so we need to times an extra 2. So 0.5 times 2 times the how much 18 is equal to 20.52. Then it's an answer. So these are the answers. Okay. Volume to volume stoichiometry. So volume to volume stoichiometry. So we know volume. So we know the moles of gas. So 8 moles of gas. So when it's in 0 degrees, it's 22.4 liters. But we know they will just become bigger or smaller in different temperatures. So when it's 25 degrees or normal temperature, it's 24.5 liters. Okay. So the mole ratio is the volume ratio. Okay. So volume to volume stoichiometry is a question. So this is the equation. So combustion, this and produce carbon dioxide and water vapor. So the combustion. So what's the volume of oxygen is required to combustion? This is the number of the reactant. And what's the volume of carbon dioxide? Okay, so let's asking for oxygen and carbon dioxide. So 0.65. Okay, so 0.65 and it's already the volume ratio is equal to the mole ratio. So it's simple. We just check it because we can see oxygen's coefficient is 5 and this coefficient is 1. So this is 5 times more. So 5 times the 0.65 liters. And 0.65 times 5 is equal to 3.25. So 3.25 liters. So it's 3, okay? So another, but we see coefficient is 3. So 3 times the 0.65 is equal to, okay, it's equal to 1.95 liters. So this is the answer. Mass volume stoichiometry. Another. So we need to know it. Why? So it's important because when you are to make a car, you need to make an airbag for safety. But when it makes too much reactant, they will burst airbag. But if too little, it's not safety. They'll boom, just bam. Okay. So you need to measure the amount of it. Okay. So it's important. You see, 2 aluminum. Okay. 2 aluminum metal and plus this is the equation. Okay. So what is the volume of hydrogen gas at STP? With 2 grams of aluminum is react. So STP is 22.4 liters of any gas. Okay? So 2 grams of aluminum. Okay? So 2 grams. So we can see, so we now need to change into mole ratio. So how to do it? So we need to know the molar mass. So we can find on the periodic table, we find is 27. So 2 divided by 27 is equal to 0.07. Okay? So so we need to know the ratio. 0.07 over an unknown number x is equal to the coefficient is 2 and 3. Yes, 2 and 3. So equal to 2, 3. So cross times. So 0.07 times 3 divided by 2 is equal to 0.105. So this is moles, but we need to change it back into liters. So we remember it's the STP, so it's 22.4, and we times it together. Times 22.4 is equal to 2.35. So it's the answer, 2.35. Ooh. Okay, so to the next page. Volume mass problem. Okay, volume to mass problem. Okay, another. We change from volume to mass. First, what mass of calcium oxide is required to react with this liters of sulfur dioxide? So this sulfur dioxide. Okay, so first we need to remember we need to count this acting this liters. Okay, so we need to know how many moles. So we divide the liters, not the mole mass. So 1.4 times 10 to the power of 3, or you said 1.140 divided by 22.4. What's our calculator? Divided point first. Yes. Okay. So it's equal to 62.5. Whoa, what? This happened? Right here. Let me wait a second. So this should be right here. Okay. So yes, it should be right here. So we find the number 62. Hey. Why is this always happening to me on me? Okay, so we need a pencil. Okay, and it's 6. Okay, so now we need to times the molar mass to get grams. But now first we need to see all of this is 2, 2, 2. So there's nothing to do. Okay, because the coefficient is 2, 2, 2. So we can change it to 1, 1, 1. Same. So then we just times the molar mass. But how much is the molar mass? So molar mass you can find Ca plus oxygen should be 16. Okay, it's about 56.08. Okay, so then we times 56.08 is equal to the grams. So we do times it. Wow, a big number is 155 grams. It's very big number, right? Okay. Well now, okay. Limited reactant and excess reactant. So limited reactant. So sometimes that you don't have enough oxygen or reactant, so the other reactant won't use all the reactant because some may have less or maybe no. Okay, so some is excess, that you will lack some of them. So let's see questions. The first question. So you have silver and sulfur. It sounds very similar. Silver and sulfur. Okay. So you have 15 grams of silver and 10 grams of sulfur. So most people think that the silver is excess and the sulfur is limited because it's only 10 grams. But actually silver is very expensive, so it's not really possible. Okay. So let's do it. So but you just think, but it's not real because you can see. The molar mass of silver is very big. It's 107.87. Yeah, I write it right here, okay? Okay, so we need to know how many moles to calculate it. Not mass ratio, it's mole ratio. So we need to use 15 grams divided by 107.87. Okay? Okay, 0.87. Okay, so we need to divide it and what? Wait a second. I think, okay, divide it and then we get how much? We get points. Okay, we got, wait a second, let me just do it. Divided by 7.87 is equal to, okay, 0.463 blah blah blah, and can round it to 4. Okay, so this number, and then we need to do sulfur again. So this we just keep it right here. So sulfur is how much? So sulfur is just 42.7. Okay, 0.07. So we just do it again. So wait a second. Okay, so we need to do. But oh, wait a second. We need to find the coefficient. It's not very fair. So it's 2. There's only, so we need to divide this number by 2 because it's 2 silver, and then we get 0.232. Okay. So then we just do to sulfur. So how much? 10 grams. So 10 grams divided by sulfur is this number. Okay, so we get this number. Okay, so now we can compare it with this number. So actually this is greater, so this is excess. Sulfur is excess. So silver is limited because silver is very expensive. So that's the reason. Okay, so you need to do it, not just look it. Just use your eyes and think. So what is, okay, so theoretical yield and percent yield. So theoretical yield, because maybe sometimes when you want to use, you want to make oxygen, or you want to make hydrogen. We know hydrogen is very, very light, so it will just float on the air, so it's not easy to get it, okay? So, how to do it? So we need to see, now we can get all the product. So theoretical yield is how much it should, and percent yield is how much you get. Really. So first, like this ways. Okay. Okay. So 30 grams of this is decomposed. Okay. So what is the theoretical yield of a gas? But if the gas is only this, so what is the percent yield? So the theoretical yield we need to calculate. 30 grams, so we need to know the molar mass because we need to change into mole ratio. So 40 divided by the molar mass, 122.5, I wrote it right here, 0.33, about 0.33, okay? Moles, this is actually the number, and this over x is equal to the ratio. It's 2 and 3. We can see the coefficient is equal to 2 to 3. Okay, it's 3. Okay, and then we cross times. So then we find cross. So it's about 0.5, not actually 0.5, I find it. Because if you times this together, it's not really equal to 1, it's equal to 0.9999999. But it's about 0.5, okay? So 0.5, then what do we need to time? 0.5 times oxygen, because we get oxygen, okay? So 0.5 times oxygen is 32, so we get 16 grams. But we only get 30.9, so 14.9 over 16. Zero point 0.93939. Hey, hey, okay, 93125. So we don't need this; it's too small. So we can just change it into 93%. So then it's